Jai Hind, myself Dr. Ankita Agrawal. Today here I am going to talk about atomic structure and periodic properties. 12 nature of matter. In case of light, some phenomena like diffraction and interference can be explained on the basis of its wave character. Louis de Broglie in 1924 extended the idea of photons to material particles such as electron, and he proposed that matter also has a dual character as wave and as particles. So lambda is equal to h upon mv, where lambda is wavelength, h is Planck's constant, m is the mass of a particle and v is the velocity. Wave mechanical model. The wave mechanical theory proposes that each electron circling an atom's nucleus occupies a specific orbital and spins a certain direction, but the orbital is like a cloud or wave of energy, not the ring you might imagine thinking about the Earth's orbital around the Sun. Heisenberg uncertainty principle. The Heisenberg uncertainty principle states that it is impossible to know simultaneously the exact position and momentum of a particle. That is, the more exactly the position is determined, the less known the momentum, and vice versa. So, mathematically, we describe the uncertainty principle as the following: delta x into delta p greater than equal to h upon 4 pi, where x is position and p is momentum. Schrodinger wave equation. The Schrodinger equation is a linear partial differential equation that describes the wave function or state function of a quantum mechanical system. The concept of a wave function is a fundamental postulate of quantum mechanics. The wave function defines the state of the system at each spatial position and time. Quantum number. A set of 4 numbers through which we can get the complete information about all the electrons in an atom, be it energy, location, space, and type of orbital occupied, and even the orientation of that orbital is called quantum numbers. There are a total of 4 quantum numbers. First is principal quantum number, it is denoted by small n. Second one is angular quantum number, it is denoted by small l. Third one is magnetic quantum number, it is denoted by small m. And last one is spin quantum number, it is denoted by small s. AUFBAU principle. The AUFBAU principle states that in the ground state of an atom, an electron enters the orbital which lowest energy first, and subsequent electrons are fed in the order of increasing energies. The word Aufbau in German means building up. Here it refers to the filling up of orbitals with electrons. Pauli exclusion principle. The Pauli exclusion principle states that in an atom or molecule, no 2 electrons can have the same 4 electronic quantum numbers, as an orbital can contain a maximum of only 2 electrons. The 2 electrons must have opposing spins. Hund's rule of maximum multiplicity. Hund's rule states that every orbital in a sublevel is singly occupied before any orbital is doubly occupied. All of the electrons in singly occupied orbitals have the same spin. Atomic radius. The atomic radius is defined as 1/2 the distance between the nuclei of identical atoms and are bonded together. Ionic radius. The ionic radius is the measure of an atom ions in a crystal lattice. It is half the distance between two ions that are barely touching each other. A typical value for an ionic radius would be from 30 picometers to 200 picometers. Ionization energy. Ionization energy is the energy required to remove an electron from a gaseous atom or ion. The first or initial ionization energy of an atom or molecule is the energy required to remove 1 mole of electrons from 1 mole of isolated gaseous atoms or ions. Electron affinity. The electron affinity of an atom or molecule is defined as the amount of energy released or spent when an electron is bonded to a neutral atom or molecule in the gaseous state to form a negative ion. Electronegativity. Electronegativity is a measure of an atom's ability to attract the shared electrons of a covalent bond to itself. If the two atoms of the bond are of equal electronegativity, the electrons are equally shared. If one atom is more electronegative, the electrons of the bond are more attracted to that